Okay, so picking up from where I was, didn't quite get through to my last point there. What I'm saying is that when you add all these up, you'll get the perimeter. So we'll simply add 20 and 30, which is 50. So we'll have 66 centimeters for the perimeter of that triangle. So consider this video 10.1 B or something like that. I don't know. So we filled that in already. And now we're on to section 12.2. So a chord is a segment whose endpoints are on a circle. So because that is red, I'm going to show you that this is a chord. Okay. And this is also a chord right here. And another way of looking at that, a chord is also called a secant line. So it's a secant line when it cuts through twice, okay, and a tangent only cuts through once. So a chord is a segment whose endpoint are on a circle. First bit of vocab. Pause the video if you need to write this down. Here are a couple of theorems. So the first one is that chords that are equidistant, the same distance from the center, are congruent. So let's look at that. And congruent chords are equidistant from the center. I guess it's kind of saying the same thing, just the converse of it. So what do they mean by equidistant from the center? That's kind of an important thing to understand, so maybe we should kind of draw that in. So let's draw in our center. Let's see what I can do for a quick supporting diagram. Give me just 1 minute to think this through. So how do we know if something is equidistant? Well, I guess what we'd have to do is we'd have to measure a 90-degree angle off of it. So what you'd have to do is, let's just draw in two chords here. This chord right here and this chord right here. So what we'd have to do is we'd have to find where the chord is perpendicular to the center. And that's going to be your shortest distance. So that's what they mean by the equidistance. That's important to understand. And what that then is telling us is that they're congruent. So this chord is congruent to this chord. And you can flip it, of course. So congruent chords, which are the two green, are equidistant from the center. So equidistant, meaning that this distance is the same as this distance. I'm sorry that's so ugly, but that was the best I could do. So that's a theorem you just have to be aware of. And remember, when you're doing the distance, you want to draw a perpendicular to that line. That's how you get the shortest distance. All right, so we did that. And now we need to solve for x. So let's see. Here's what I would do for this one. I'm going to do this one. This one's going to be a now you try. So feel free to pause the video and try that in just a moment. So on this one, because these are both 18, that's 36 together, 18 plus 18. So I would say this chord is congruent to this chord. And if that's the case, then x must equal 16. They must be the same distance. Also note the 90-degree angle right here and right here. That's important to note because if they weren't 90-degree angles, you wouldn't be able to figure out the distance. Okay, so that's that. Why don't you pause the video, try the now you try. And here we go for another few theorems actually here. So here are a few different ones. So in a circle A, we want to fill that in with diameter. And actually, I think I have these all written in. So let me just go to where I have them all written in. Perfect. So there we go. In a circle, a diameter that bisects a chord is perpendicular to the chord. Okay. So a diameter bisects a chord that is not a diameter is perpendicular to the chord. A diameter that's perpendicular to a chord bisects the chord in its arcs. The perpendicular bisector of a chord contains the center of the circle. So hopefully we can do some work with that. This video is going to end eventually, but pause it and try to write those things down. And try to just understand what they're meaning. So we're getting close to the end. I think this is the last one we want to have here. So let's just look at this diagram and just kind of just pick it apart a little bit. So they gave us a diameter of QR. It's cutting SU rather. And what's going on here? Diameter that's perpendicular to a chord bisects the chord at its arcs. So let's say, for example, this is right here. This is 90 degrees. If it's 90 degrees, we know that TU is equal to TS. These are congruent. So this is congruent to this for that reason. And that's kind of the same thing if we have it the opposite way. And also just be aware that anytime you have a circle with a chord and you take half of it, so you go halfway between right here, and you have a 90-degree angle, that's always going to contain the center of the circle. So that's that last part. So that's kind of where we need to be with this problem, and I think that is it. I just want you to do this one as a now you try. So this is your now you try, and we will kind of cut the video there. So make sure you get this done, and I will see you soon.